In this example, we're going to work with the negative angle identities and also with the periodicity identities. And these identities here are, what they say is that if you're on angle T, for example, and you go around one turn, you end up where you started. It's like having coterminal angles. Let me make a small illustration here. If my angle is in the first quadrant, angle T, and I go around 2 pi plus T, notice I went around T plus 2 pi, I end up at the same place. So my cosine, the original cosine, is going to be the same exact value for cosine when I go around one turn, and etc. This also works for going around twice, 4 pi instead of 2 pi, or 6 pi or 8 pi. And I can add 2 pi or subtract 2 pi. So this not only works for 2, it works for any multiple of 2. Okay? For tangent, we don't use 2 pi because it is true for 2 pi. But with tangent, it'll also work for half a turn. Instead of going around the whole way, I can go around half, like this. Let's say this is my angle T. And I can go around T plus pi, which would bring me over here. And the tangent at this point would be the same identical value as this one here. Here I'll have a positive sine over positive cosine, which will give me a positive tangent. And over here I'll have negative sine over negative cosine, which will also give me a positive tangent. So for tangent, the values repeat at shorter intervals. It will repeat every pi. Okay? So for tangent, this identity works not only for 1 pi, it also works for 2 pi, for 3 pi, because when I go around halfway, I'm at pi turn. Then I go back the other way, that's another pi turn, which is 2 pi, and then 3 pi, and 4 pi, etc. So tangent will work for 1, for 2, for 3, for 4, for 5, for 6, okay? Sine and cosine work for every 2 pi. These take longer to repeat. Okay, so 2, 4, 6, 8, 10, etc. Okay, now the instructions say that sine of t is equal to 3/5, and that this angle that we're talking about is found in the first quadrant. It tells us to use basic identities, but we're really going to use these here and the sign of the trig functions in each quadrant to find each value. Okay, so first example is sine of negative t. I have to find how much that is. Okay, I know sine of t is equal to 3/5. I want to find what sine of negative t is. And the original angle is found in quadrant 1. So I'm going to make a drawing of this, or I'm going to use the identity first, and then I will show you with a drawing. Okay, so we're going to do it both ways. You don't have to do both ways. The first way I'm going to use is using the identity. So since this is a negative angle identity, sine of negative t is equal to the negative of sine t. So this is what I'm going to do. Sine of negative t is equal to negative sine of t. This is the identity I'm going to use for this example. What do I do with it? Well, since I have, my original problem says, sine of negative t, I can write this as the negative of sine of t. And since I know what sine of t is, I keep my negative, and instead of writing sine of t, I'm going to write what sine of t is, which is 3/5. So the sine of negative t is equal to negative 3/5. And that's it for this example. That means the negative of the sine. Okay? Now, if I make a drawing This is just the visual part of it. It tells me in the beginning that my angle is in the first quadrant. Okay? And it tells me that the sine here, which is my y coordinate, is 3/5. And they want me to find what the value for sine is, but at the negative angle t. So if I were to draw the negative t angle, it would be down here, right? Negative direction. This is negative t. Now, the coordinate, my y coordinate in this case, according to the negative angle identity, it says that it will be the same value as the sine of t, but negative. So the coordinate here would be negative 3/5. And that's what we found. So we did it both ways, using the identity and using a drawing. Let's do another example. Example 2. This one is a little bit more complicated. It says sine of 2 pi minus t. Now notice that this looks like the periodicity, I don't know how to say that word, periodicity identity. This one here. But it's a little bit different because this is t plus minus 2 pi. And here I have 2 pi minus t. Okay, so I'm going to rearrange this so that it looks like my identity so that I can use it. Okay, so what do I do to make this look as t plus minus 2 pi? This is what you do. I'm going to rewrite this. I'm going to factor out a negative here. Watch. Sine of negative t minus 2 pi. What I did here is I factored out a negative, and now this looks like the identity that I had originally. Okay? Now I take this negative and I say to myself, well, this is a negative angle identity that I've created here. And it says that the sine of the negative of this angle should be equal to the negative of sine of t. So let's write that. This is going to be equal to the negative sine of the angle, which is t minus 2 pi. So let's go back. I factored out a negative in this expression. Here's the negative I factored out. If I multiply negative times t, I get my minus t. If I multiply negative times negative 2 pi, I get my positive 2 pi, which is what I had originally. So all I did was try and rewrite this as I see it in my identity by factoring out a negative. Now, once I factored out this negative, I said, well, now this became a sine of a negative angle, and here's my negative angle identities. Here's the sine of the negative angle, and it tells me that the sine of the negative angle has to be equal to the negative of the sine of the angle without the negative. So that's what I wrote, the negative of the sine of the angle without the negative. Okay? I hope this doesn't confuse you. And now that I have the negative of the sine of t minus 2 pi, now in this step I can rewrite the sine of t minus 2 pi by using this identity here that says the sine of t plus minus 2 pi is equal to the sine of t. So the sine of t minus 2 pi, this piece here, my identity says is equal to sine of t. Notice that this negative I carry, I keep it, and I change this into sine of t, because that's what the identity says. Whenever I have t plus or minus 2 pi, that will be equal to the sine of t and the negative that I carried. So that will be equal to negative, and we know what sine of t is because they told us at the beginning. They told us sine of t is equal to 3/5. So I substitute sine of t for 3/5. And my answer here is negative 3/5. So here's my answer. Sine of 2 pi minus t equals negative 3/5. Okay? And there it is. If I make a drawing of this, they told us in the beginning that the original angle is in the first quadrant. If I try and draw 2 pi minus t, this is what it would look like. I would have to go around one whole turn, that's 2 pi. Minus t would be going around 2 pi and coming back t. So my turn would stop here instead of here. Okay, and this would be your negative t. So notice that this is equivalent to my negative angle identities. That's why when sine of t is 3/5 here, it's going to be negative 3/5 here. And that's what we got. This drawing is just for a visual of what's going on in the coordinate plane, but you can just work with the identities. I hope you understood. Go back, try it yourself, and check your answers, and I will see you in the next video.